Okay, well, guys, welcome again. Welcome to the channel TCP/IP. Today, we are going to discuss about the routing. As we know that routing is very much important, and routing is what one of the function of network layer. So let's start with the routing. In this lecture, we are going to discuss about why routing is required, what is the purpose, and then what is routing and how it works, the exchange of tables. Then we'll discuss about some cost metrics, and then we'll focus on the types of the routing, that is adaptive and non-adaptive, and then we'll discuss about the static versus dynamic routing. So let's start with the first agenda. So why routing? So we all know that there is a routing is a function of network layer. So what is the purpose? So before discussing the purpose of routing, what is routing? So let's discuss why routing is required. So if you say that, let's say, because we know that the network structure in this era is very large. So if the structure is very large and network size is very large, so we definitely there will be multiple paths are available. So if the multiple paths are available, so definitely we can have a decision capacity, and that decision capacity will be taken by the routers. Second will be a distance. As we all know, the nowadays the network is going far away. The size can be 10 kilometers, 100 kilometers, 1,000 kilometers, or more than that. So again, here at each every number of hops and distance, when we have to take the decisions so that my packet datagrams will transfer from the source to destination effectively. So distance is also one of the reasons that's why routing is required. Then IP address hierarchy. We all know that the IP addresses are going to be assigned, and the top level directory, sub level directory, or let's say big zone, small zone, so that okay, the subnets can be identified easily, and the routing can be, or let's say decision can be taken properly. Let's say if you want to go to the any place, we generally ask the bigger place name, then we go to the sub place name, and then we go to the actual what we can say the house name or plot numbers. Okay, in this way, because IP address hierarchy in very hierarchical structure or very deep structure, and that also the source to destination is very far away. So we need to have their IP addresses, subnet mask, their sub networking, etc., etc. This kind of hierarchy support so is there, and to identify the datagrams on this hierarchy, we require again a router. Then the fourth will be data transfer. We know that there are various natures of the data transfer like unicast, multicast, and broadcast. Here, our ultimate aim is to transfer our datagrams for the source to destination. So, who will assist? So, routing is going to be assist, or router is going to be assist for our datagrams. So, this is what the purpose of routing. Let's start what we mean by routing itself now. Now, here, if we talked about the today's internet, so today's internet is what the combination of networks connected by routers. So generally, datagrams goes from many routes till it reaches to the destination. Like we have discussed in the circuit switching, packet switching, and message switching. We have plenty of intermediate nodes or routers are there, and datagrams travels from the source to destination effectively. But their decision is required, and we also know that the network layer is connectionless. We manually will not establish the connection, so that we need a mechanism that can help us to travel datagram across the network. So in case of the connection less, there is no any fixed path available. Anyone can wander from any place, any route. So here, selecting the one on the basis of some criteria. For that purpose, also the routing is required. Here also more about this. Routing is a path or way. We can say the routing is a medium or path or way through which the datagram can be reached to the destination. This is what the first simple definition. A network routing is the process of selecting a best path. This was the best path, because if we have a network very large, there are multiple paths are available. So out of that, selecting a best path. Best path can be on the basis of cost, number of hops, or traffic, etc., etc. So this is also a purpose, and that routing is routing. Then internetworking, the process of moving packets of data from source to destination. These are the three in common definitions are available about the routing. Then routing is a key feature of internet because it enables messages to pass from one computer to another computer and eventually reaches to the target machine. This is what another definition of the routing. And routing is usually performed by a dedicated device called as a router. So we have discussed the router and router configuration in some separate lectures. Please, if you want more details about the router configuration, you can see that video also. But here there is a note. Routing is the often confused with the bridging, which perform the similar function, but both works at the different layers. Okay, because we know that the bridge layer which work at the hardware layer and the switch works on the software layer. Like, okay, router works at the software layer, let's say internet layer or maybe the network layer, whereas the bridging is work on the lower level like physical layer or let's say data link layer. So these are the definition of the routing. So let's start the another. There is a one a unit we can say associated with the routers, and that unit is what the cost or matrix. So is a networking device that has a data structure called a routing table. In routing table, we can have a source, we can have a destination, we can have a cost as a matrix. Okay, so all topological information is going to be stored in the routing table. Uh, so that on the basis of the routing table, the router going to be take the decision. So then matrix is typically one of the field in routing table. So as I discussed, let's say there is a cost is there. So cost is what the one of the field to take the decision. Okay, router matrix help the routers. So this matrix is typically filled to take a decisions on the basis of something. So to choose the best route among the multiple feasible routes, because there are multiple, let's say there is a source and there is a destination. It can be high, it can have multiple paths available to reach. Okay, so out of this, which one is best? So let's say this one is best, this one is best, or this one is best. Okay, so let's say I have cost of V1, so I can choose this route is what the best. So this is what the function. The router metrics are the metrics where decision should be taken to travel. So decision is again going to be taken on the basis of some metrics. Metrics are the cost value used by the router to determine the best path to the destination network. For example, there are multiple metrics are available like number of hop counts, the bandwidth of the network, then the delay, how many delays is there, the load, how many loads are available, whether the network is reliable or not, what, then the MTU's maximum transfer unit, what is the size of carrying, what is the size of that MTU of that on that router. So these are the number of metrics available. On the basis of this, we can take a decision to transfer our datagram for source to destination. If I talked about the number of hops, let's say if I have a I have a B, and let's say C. So here A and B we have one hop, B and C what we have a second hop. Okay, bandwidth is carrying capacity. Except so all these parameters are available to take a decision so that the datagrams can travel from the one to source to destination actually. But here there is a note also. The high cost is a bad news, where the low cost is a good news. So we generally follow the route which is what very free, which is very convenient for us. So increasing the cost is very bad news, but decreasing cost is very good news. Okay, so let's talk with about the working, how these routers are going to be working, how the routers are going to be exchange their tables. So this figure is adopted from 9tutorial.com. So let's start with the step number one. Let's consider three routers: router A, router B, and router C. Router A is having the interface E0 and E1. The router, generally what we have, router maintains the directly connected network entry only. Okay, initially, once before the enabling the routing. The router B having the E0 and E1, where router A has 1.0, 1.0.0, and the router A also had 2.0.0.0. As like the B 2.0 is there, 3.0 is there, and the router C, which is 3.0 connected, and the 4.0 connected. So these are the first step where router maintains initially their directly connected entries. Let's say how these tables are going to be exchanged and the decision can be taken. Let's say second time A send to the B. So A sends his routing table to the B. So let's say what A have 1.0 and 2.0. This is what have. But what B have 2.0 and 3.0. Out of this, the table is going to be compared. Table is going to be compared whether do I have the entry of 1.0. Router B will say, I don't have entry, so please accept it. So he has accepted. And rather than 2.0, it is already have. So need not to be accept here. Okay. If there is a better path is available, so he can accept. Otherwise, it is not going to be accepted. Go to the third step. B sends to the A. Now B sends to the A. What B have 2.0, 3.0, and 1.0. B sends to the A. Now A will check whether do I have 1.0. Yes. So need not to take again. So reject it. 2.0. Yes. 2.0 is I have. So need not to be there. And then 3.0 is new to me. So accept it. 3.0 is new to me. Accept it. Meanwhile, this same process will be happen. So here then B sends to the C, then vice versa, and the C sends to B, and the B sends to A. So every router now get, let's say, all the four networks available: 1.0, 2.0, 3.0, 4.0. So every router comprises of now all the networking information with their networking IDs. So in this way, the routers exchange their tables. If we have router configure, if you have static configuration on the basis of that protocol functionality, they exchange their routers to their neighbors. Okay, so every neighbor send their tables with their neighbors. So in this fashion, everyone will have a latest information about the network and topological information, so that the router can take the proper decision to reach the datagram from the source to the destination. So this is what the function. Let's talk about how, if any changes occur in the network, how it is going to be reflected over here. Let's say if C 4.0, C router 4.0 directly connected has get down. Okay, it get down. Let's say how this is going to be mentioned. So first of all, C will maintain that I have a link has broken in the down. Let's say so I need to disseminate my table to the others. Then C will eliminate that particular entry. So C will transfer their neighbors, whose neighbors of the C is B is neighbor of the C. So B will inform to this particular B. Now the C and B have their own entry will be removed or from here, or let's say keep for some time it is idle, and then B will send to the A, so that everyone knows that okay, there is no any path to reach to the 4.0, so that they cannot take a bad decision to transfer the datagram from the source to destination. So these all the changes are going to be again replicated over the every routers. Then there are two what we can say the types of the routing or routing tables. So generally it is what first is a static and or else non-adaptive. This is the one manual entries are there. Now what is static routing? In static routing, system administrator generally configure their networks via some commands with the static nature. Once they configure all the networks, on the basis of that only the decision can be taken, or that number of networks can be added over here. But what are the advantages and disadvantages? It is easy to implement in a small network. If we have a small network, the static routing is there, because if I have a thousands of routers, we cannot manually maintain the thousands of databases over each time by system administrator. It is very secure because we know that all the tracks of these small networks, it is very secure. No advertisement are sent, so no exchange of messages going to be done because it is static one. Unlike the dynamic routing, it is very predictable, as the route to the destination is always as the same, because we know the fixed path is available. No routing algorithm or update mechanisms are required. There is a no routing algorithm. There is only a static configurations available. Therefore, extra resources like the CPU and memory is not required. But there are some disadvantages. It is suitable for simple topology or for special purpose such as default static route. It is limited in space, limited in what we can say functionality. The second drawback, configuration complexity increased dramatically as the network grows. So here the complexity will be increased if the size grow. Managing the static routing is larger network will become very time consuming. As I told you, thousands router there, thousand router database need to be maintained in routing tables. If the link fails, this is very important. If the link fails, the static routing cannot reroute the traffic. So it is not going to be rerouted traffic. So there definitely the loss will be there. There is definitely packet loss will be there. Okay. Therefore, manual intervention is required to reroute the traffic. So this is what the static routing. Let's talk about the second type of routing. That type of routing is called as what the dynamic routing, where whatever the updates are going to be taken or placed in the network, that all the updates are going to be replicated over the table, as I showed in the working. Any link failure, etc., that is going to be replicated on that. And that can be many of reasons. Many reasons can be, let's say, new node added, router added, or maybe network added. So all the information is going to be updated in this routing table. Okay, this is what the routing table. Second can be interface action, like interface up and interface down. That information also going to be replicated so that we can take a proper decision. Then updated information, if any updated information is there, that is going to be replicated, or any changes occur, all the changes are going to be disseminated at the trigger level to the in the dynamic routing protocol. Let's see, there are some advantages. This routing is suitable for all the topologies where multiple routes are required, no issues. Then generally independent of the network size, it is also again the very good advantages. No administrator roles after routing the enable on the router. So once that administrator have enabled the routing with the help of any protocol, so it is automatically going to be done for many of times. So it is not going to be tedious work for the administrator. Automatically adopt the topologies to reroute the traffic if possible. Yes, it is very good advantages, but there are some disadvantages. Can be more complex in initial implementation. Okay, that on the basis of the protocol we have to take. Let's say if I have a RIP protocol, OSP protocol, so we have to take the measures of that protocol only. So it is one time effort is what that. Less secure due to the broadcast and multicast. This is what less secure due to the broadcast and multicast routing updates. Additional configuration settings such as passive interface, routing protocols, authentications are required to increase the route security. So security is problem because the routes and all the things are going to be dynamically changing. Route depends about the current topology. Whatever the current topology at that instance, that time the route is going to be decided. If I have multiple routes, one can select. It requires additional resources like the CPU and memory and the like bandwidth to maintain all kind of information. But moreover, dynamic routing is what now a need of today's, what we can say. Then let's take the difference between these two terms very quickly. The parameter is what the route decision. In static routing, route decisions are user defined, whereas in dynamic routing, dynamic routing routes are updated according to topological changes and trigger updates. Whenever there is a changes occur, it can be automatically updated to that table and decision can be taken. The process. Static routing is manual by system administrator, whereas dynamic routing is automated by the routing protocols. And then security, it is high secure, static routing high secure, whereas the dynamic routing is very less secure as compared to the static routing. Occurrences, it is one-time process and it is repetitive process. Used for what used for the static routing is implemented in the small networks, whereas the dynamic routing is implemented for the large network. A decision, who is going to take decision? Static decision based on the old information and the still information, and dynamic decision as per the latest information. This is what the correct information. Affects. In static routing, failures of link disturb the routing. This is what a very important point, that if there is a link fails, then it disturbs the rerouting. Okay, and whereas in dynamic routing, failures of the link does not interrupt the rerouting. Additional resources, static routing does not require any additional resources like the CPU and etc. memory, but the dynamic routing requires additional resources like memory, bandwidth, etc. The protocol, static routing may not follow any specific protocol, but in terms of the dynamic routing, they follows the BGP, the border gateway protocol, the RIP, routing information protocol, OSP, open shortest path, first protocol, and this latest one, EIGRP. These are the protocols are going to be used by the uh, dynamic routing. So these number of differences are available. So I hope guys the differences and what kind of routing and how routing is going to be done, it is understood by you. If not, please write the comments in the comment box and you can take the another review address. Okay, so thanks guys.